Welcome to a sim code. Want to see how much fun coding can actually be? Hit subscribe and let me show you how we can turn those lines of code into something awesome and maybe add a little spark while we're at it. Sequential search, also known as linear search, is a simple algorithm used to find an element in an array by checking each element one by one from the beginning to the end until a match is found. It works by iterating over the array, comparing each element with the target value. If a match is found, it returns the index of the element. If not, it returns -1 to indicate that the target is not present in the array. While this method is easy to implement and works on both sorted and unsorted arrays, its time complexity is O(n), meaning the time it takes increases linearly with the size of the array. As a result, sequential search is efficient for small arrays, but can be slow for large datasets. Despite this, EDA is a useful introductory algorithm that helps understand basic searching concepts and is a great starting point before learning more advanced search techniques like binary search. Standard input-output library for basic I/O operations. Function, sequential search. This function will perform the sequential search, linear search on the array. To find the target element, it takes an array of integers, its size, and the target. Integer to search for as input. If the target is found, it returns the index of the target. If the target is not found, it returns -1. The ARR is the array where we will search for the target. Size is the total number of elements in the array. Target is the element we are trying to find in the array. The search process. Sequential search checks each element in the array one by one. Starting from the first element, index 0, and continuing until we find a match or the end of the array. If we find the target, we return the index of that element. If not, we return -1. Check if the current element in the array matches the target. If the element at ARR, I matches the target, we return the index I where the target is found. If we complete the loop and do not find the target, we return -1. This indicates that the target is not in the array. Let's define an example array of integers. This array will be searched to find the target element. Target element we are searching for in the array. Calculate size of the array dynamically. Explanation of dynamic size calculation. This is a simple trick to get the number of elements in an array, regardless of its size. It works by dividing the total memory size of the array by the size of a single element. Call the sequential search function to find the target in the array. If the result is -1, the target was not found in the array. Otherwise, the result contains the index where the target was found. Target not found. Target found. Print the index where it was found. End of the program. Return 0 indicates successful execution. Final thoughts. Sequential search is a great introduction to searching algorithms. It's intuitive. You go through each element and check for a match. If the array is small or you do not know if it's sorted, sequential search is often the go-to method. As you progress in algorithmic thinking, you will learn that there are faster and more efficient algorithms out there for larger datasets. Now run our code. If you liked this video, don't forget to like and subscribe for more.